lesson is about permutations, and it's very closely related to our last lesson that was about the fundamental accounting principle. It looks like we have a lot more slides, but some of them are going to go very quickly. We've already finished that title slide, and look at this one. No math on there. This is an introduction. Some of you may be familiar with it, but a math symbol that indicates something we do is an exclamation point. I often have students tell me that they've seen the exclamation point on their calculator before, but had no idea what it was for. And that really is just going to depend on your math background. When we see an exclamation point behind a number, though, we call it a factorial. And it indicates to us that we should multiply a series of descending natural numbers. Now, some people actually do it ascending, but it's easier to start with descending. And what are the natural numbers? So natural numbers are the numbers you can count on your fingers and toes. It starts at 1, 1, 2, 3, 4, but we're going to be going backwards, so we'll stop at 1. So when we see something like this, then it simply means that we're going to 2 factorial is going to equal 2 because it just indicates take 2 times 1. 3 factorial is 3 times 2 times 1. 6 factorial then, definitely going to be a little bit harder, but it indicates. So you can see if you wanted to start at 1, you just stop at the number that's out here. And so a way to write that down is to say n factorial is going to go from 1 times 2 all the way up to n. But I always just go down because then sometimes I don't have to keep writing them all, and you'll see that shortly. So if we're going to multiply 6 times 5 times 4 times 3 times 2 times 1, I already don't want to do that. $720. Then we can do division within this. Now, this is where I was saying I don't write them all out, because whenever you've got division, what happens is that if you're looking at your denominator, it's got 4 multiplied down to 1, but that's also going to be in the numerator, so we can just know that parts of that are going to cancel, and we are left to multiply what's left. So let me bring that up, and we won't ever have to find out the whole thing. We can just do 10 times 9 times 8 times 7 times 6 times, well, I didn't do times 6, did I? I know the order doesn't matter, but I like it to look right. Times 6 times 5. And then the 4, 3, 2, and 1 all canceled. So that is 151,200. So the reason it says hang on to this information, we'll probably come back and look at this slide closer to the end because there's something else I want to show you, but this particular purpose was just introducing what that exclamation point, what factorial means. Now, how do we use it? Well, I've got several slides that'll go pretty quickly here, but like suppose that you had 6 arcs on the rainbow. And this does just have 6 arcs. I know when I was a child, they taught me the colors of the rainbow were Roy G. Biv, which was 7 arcs, but I've got a note here, indigo never meant anything to me anyway, particularly when you're a first grader and somebody's going to have you color a rainbow. So suppose you hand these coloring sheets and you hand a group of bright markers to some first graders and say, color the rainbow. Use a different color on every stripe. Now, are all of the first graders going to color the rainbows the same way? Almost certainly not. So how many different ways could they do that? Well, here's just a couple of options of what you might get back. These are not the same. You can just tell at a glance they're not the same. However, these do use the exact same colors. So how do we say they're different if they've used the same colors? That math word is permutations. Permutations refers to the different arrangement of things. So there's not any different colors there, but they're arranged differently. So anytime you have a group and order makes a difference, you are dealing with a permutation. Now, is it possible to have a group and order doesn't make a difference? Yes, like I could just go to the library and check out 6 books, and if they're not part of a series, then there's no order, it's just 6 books. But there are some things where order makes a difference. If I check out a series, then I'm going to say this is book 1, this is book 2. So there's batting order, shift order, and here I'm thinking about like morning shift, evening shift, night shift. Okay, officer ranking, because president versus vice president, you know, treasurer, there's always a ranking. And when you put books on a shelf, you might think, well, I don't care how those books are on the shelf, but there is a book that is first on the shelf and then second on the shelf. So there's still an order to it, even if it's not important to you. Things that do with order has to do with permutations. Now, we can find out exactly how many different ways the kids can color the rainbow with these markers by using our fundamental counting principle by before. If they're going to use a different color on every one, then when they very first start out, they have 6 markers to choose from. And after the first marker, they have 5, and then 4, 3, 2, 1. So every time they're going to color a rainbow, they're choosing a marker. And then this is how many choices they have. But what you see is, since it started at 6 and it went down to 1 and we're supposed to multiply every time, that is the same as 6 factorial. Now, did we do 6 factorial on that previous slide? Let's look at that one for just a minute. 6 factorial was 720. 720. All right, but then as we complicate things, what if the students don't just have 6 markers? What if they've got this nice box, 3, 6, 9, there are 10 markers here. Well, we can still figure this out with the fundamental counting principle. And because it is a permutation, order makes a difference. That's why we're not using an exponent. The number's changing every time. But here when they start, they have 10 markers. After they use the first one, they've got 9 left to choose from, and so on. So if we multiply all of those, 10, 9, 8, 7, 6, 5. Ooh, look, that's exactly the last thing we multiplied. 10, 9, 8, 7, 6, 5. So that's 151,200. So how is it that this one, where I wasn't doing any division, came out exactly like this one where I was dividing? Well, it's really because out of that 10 markers, they were using 6 of them. So we used our first 6 numbers, 1, 2, 3, 4, 5, 6, and then they did not use the remaining 4 markers. And so those remaining 4 markers are all of these that canceled out. So what this would indicate is that we had 10 options to start with, and there were 4 we did not use. But what happens when we get the big mega marker? Well, when you're looking at this, this is where you start to think there are so many here. Now, there are 50 markers in this pack, but they're only going to need 6. Well, I could do 50 times 49 times and on down, but this is where it's time to introduce a formula. So what is the formula when we have larger numbers? And this is the formula. It can be written as 2 different ways. I often see this first one in some textbooks, and the second one is the one that is becoming more and more common, and we'll talk about why in just a minute. But this would be like how many markers you have, and then R is how many you use. So when we are going to look at this formula, and if we're going to do 50 markers, use 6 at a time, that could be the number of permutations, and we could write 50, 6, or we could write 50 P6. That means the same thing. Both of them indicate to us that we should do 50 factorial divided by 50 minus 6 factorial, which is 50 factorial over 44 factorial. In other words, this is how many you have up here in front of your factorial. So again, this is you have, but then we're actually dividing it not by what we use, but by what is not used. So out of those 50 markers, we're not using 44 of them. So we're going to divide off those choices. Now, remembering then that 44 down is going to actually cancel out, then I don't need to write out all my numbers for 50. It's 50 times 49 times 48 times 47 times 46 times 45, and then the rest of them are going to cancel because the 44, 43, 42, all the way down to 1 will end up canceling out here. So then this is what I actually need to do. So 50 down to 45 on my calculator. Oh, and it's huge. This is going to be a common thing. Factorials get big really quickly, and so your calculator will go into what is an overflow mode. It shows you as many decimals as it can, and then there may be actually more different digits out here, but you will get a power of e. And so this is very likely to be a rounded answer, but that's not uncommon with factorials. It's just a huge number because this e to the 10th means move this decimal 10 places to the right. So whenever you have a positive number here, you're moving your decimal to the right. If you had e to a negative number, you would move the decimal to the left. So we're going to move this decimal to the right 10 places, so it's going to go around all of those digits. So I'll have 11, 44, 13, 04. Let me see if I can write that down here. 11, 44, 13, 04. Now I know that answer is not complete, but let's see if I remember the digits right. 11, 44, 13, 04. And my decimal that started here behind the 1 needs to go 10 places to the right. So 1, 2, 3, 4, 5, 6, 7. I need to go 3 more. So this is going to be 8, 9, 10. Oh wow, you get a box of 50 markers then. This is 11,441,304,000 options of those rainbows. So let's look at a word problem then. You and 19 of your friends have decided to form an internet marketing consulting firm. The group needs to choose 3 officers. Officers have rank. So we have a CEO, an operating manager, and a treasurer. How many different ways can these offices be filled? So really what looks at this is we have 19 plus you. So you actually have 20 total. You plus 19 of your friends. So read carefully, don't just grab the number. You're going to use, if we can say that about people, but we're going to use 3 from this group of 20 to fill officers. Order makes a difference because they're going to have a ranking. So this would be, which means we have 20 times 19 times and it's going to go all the way down to 4, 3, 2, 1. What's on the bottom is going to be 20 minus 3. So that's going to be 17. So from 17 down, it cancels. Okay, so that means we really had 20, 19, and 18 to figure out. 20 times 19 times 18, because 17 of them cancel. The ones you don't use, you're going to cancel. So we have 20 times 19 times 18. This represents the number of choices in the 3 spots I have. There are 20 people, but then after we choose a CEO, there will only be 19 people remaining. And after we choose a CEO, there will be 18, so I definitely typed that wrong. So 20 times 19 times 18. So that really is like the fundamental counting principle. 6,840 then. So at this point, you might very well be wondering, how is this any different from the fundamental counting principle? Well, the formula allows us to do a shortcut, and we're going to come to that, so just stay tuned. Okay, so let's look a little bit more, and we're going to go back and use a shortcut in a minute on some of these. If you're working for a sitcom television network, your assignment is to help set up the television schedule for Monday evenings between 7 and 10, and you need to schedule a show in each of 6 30-minute time blocks. Okay, that's how many we are going to use then. We are going to use 6 shows. Now we can select from among the following comedies. So this is going to show me how many we have. And I'm just going to kind of count them off here. The Office, Seinfeld, 70s Show, Cheers, Big Bang Theory, Frasier, All in the Family, I Love Lucy, MASH, The Larry Sanders Show, Modern Family, Married with Children, and Curb Your Enthusiasm. So we have 13, but we can only use 6 of them. So many ways to go about this. This means if I'm going to use 6, I can just multiply the first 6 numbers of this 13 factorial. One, 2, 3, 4, 5, 6. If I multiply those, I will have the answer. That is the equivalent of 13 factorial over 13 minus 6 factorial, which is 13 factorial, how many I have, over the ones I'm not using. If I'm going to use 6, then I am not using 7, which is why you don't see 7, 6, 5, 4, 3, 2, 1 at the end of that. Those are the ones that canceled. Okay, so several different ways to think about this. I'm not going to finish multiplying this one out. That would just be a matter of typing that into my calculator. Let's just go to some other things first. So one type of question you will run across is how many permutations of the letters could you make in a word? And they actually have some of these on your homework. If you have 3 different letters, S-E-T, it's 3 factorial, which is 6. And then they show you all those combinations. But that's not true for A-N-A, even though it seems that I have 3 letters. But these 3 letters are not necessarily distinct. Set, I could tell the S from the E, and I could tell the S from the T. You can tell them all apart. But here you cannot visually distinguish the first A from the last A. The only way that you can do that is if you do something like they've shown here and change colors of font. With the different colors, we could say that there were 6 permutations because we'd have the pink A and the blue A. However, if you turn all of those back to just black ink, then what really happens is this AAN is exactly like this AAN. ANA here is exactly like ANA here. And then NAA, NAA, you can see what really happens then is I only have 3. So how do we figure out how many options there are if there's no way to distinguish between some of our choices? This is the formula for it, which can look really confusing. So a lot of times I just like to take the formulas and put them into words. So once again, what you're going to do each time is this top number still comes from how many you have to start with. But what you're dividing by is your number of repetitions. And there may be more than one letter that repeats. That's why we've got more than one thing down here. You might only need to divide by 1. So here you can see we have in the word A, Anna, we have 3 letters, but 2 of those are repetitions. So that's why we have the 3 factorial over 2 factorial. Now the 2 factorial part cancels and we're just left with 3. So let's apply that to a couple of other things. How many distinct ways can the letters of the word Mississippi be arranged? Well, first of all, you count how many different letters do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 letters. And I'm not doing the factorial yet, I'm just trying to organize it here. But out of those letters, I have an I that appears more than once, I have an S that appears more than once, and P that appears more than once. So how many of each of those do I have? 1, 2, 3, 4 I's, 1, 2, 3, 4 S's, and 1, 2 P's. That's where I can say, okay, I'm going to have 11 factorial divided by 4 factorial, 4 factorial, 2 factorial. Now, we could work that all the way out, but again, in just a minute, I'm going to show you how to do some of this on the calculator in a faster way. So right now, I'm just setting it up, and we're going to leave that. What about ukulele? Well, how many letters do we have? 1, 2, 3, 4, 5, 6, 7. Looking at the repetitions, I have more than one E and more than one L. So I have 3 E's and I have 2 L's. So when I set that up, that's going to be 7 factorial divided by 3 factorial and 2 factorial. So now for this shortcut, and we're going to go back and finish these problems after this. If you need to get to the exclamation point on your calculator, which is going to save you having to type in some stuff, on your TI graphing calculator, that comes under math probability. But do keep in mind that if it gets really big, your calculator is going to go into scientific notation and round, maybe give you an error message. So just to get to these exclamation points, that's under math probability. I do see that this is a fraction, and different calculators kind of have some different capabilities here. So your calculator may not be able to deal with this entire fraction at once. Generally, what you'll want to do is just find out what the numerator is. So that, how do I get to that exclamation point so I don't have to type in 11 times 10 times 9 times 8 times. Again, go to math. Then this option right here, PROB, which is your probability option, since this is used a lot. And then you see option 4, and you can go down to 4 or you can just click 4. So now I have that 11 factorial that actually shows up on my screen, and I get that answer. Now, I'm going to do the denominator, which is 4 factorial times 4 factorial times 2 factorial. 4 factorial times 4 factorial times 2. And you might say, did you really have to hit that times there? I don't actually know. We can try it in just a second. So I have my numerator here, and then I have my denominator. Now I can go back up and highlight that numerator and hit enter, divided by, and then go up and hit that one for the denominator and get my answer, 34,650. This one can work the same way, but there is a possibility that your calculator will let you enter the fraction all at once. That just kind of depends on how big the kind of memory feature of your calculator is. So here we're going to try that on this one. And we're going to say 7, but then I have math. You got to go to probability. and then times 3 factorial. And that's 420. So if your calculator will allow it, you can type it all in at once. We're just going to see here, I'm actually going to go back up and repaste that and get rid of the times and see on my calculator if I needed to actually hit that. And then again, that becomes a very calculator specific thing. Okay, so that looks like that was 420 either way, so you can see I can just enter it directly. Now using that factorial then is much, much faster than typing in all the different numbers. Backing up a little bit, because I want to show you this. This is our next shortcut. There's also a way to just enter this on your calculator. And let me jump down and show you the shortcut, then we're going to come back to that slide and we will look at it. So if you want to enter permutations directly on your calculator much faster, then you need to think about it as being written like NPR. Just remember, it's kind of like the National Public Radio then, NPR. And so your N is how many you have. You enter that number first, and then you go to get your permutation key. So we'll talk about that in a second, and then enter how many you're using. Now to get to this permutation key, it's also under math probability. It's just the second option. So let's go here and let's look at this problem then. If I wanted to do this one just directly on my calculator, I can hit 20 first, go ahead and hit the 20, and then math, go back over to your probability option, and you see this number 2 has a P in it. It automatically made that 20 nice and small, and so then I can type in the 3. Now if you have the newest calculators, you don't actually have to type the 20 first. So like on this one, if I hit math and I go to probability, option 2, it just puts the blanks there. But if you've got a little bit of an older calculator, it is important that you hit that 20 first. And so it's generally best just to go ahead and be in the habit of that, because the newer ones will work either way. So we can enter that directly. That's also under math probability. And typing that in, as you can see, it's much, much shorter. Even with all the writing I didn't bother to do, it's still shorter that way. Look at this one that we did then. I could just go 50p6 on my calculator. And I get that same answer I had before. Now, in fact, it's just one last little trick here before we finish up. Another thing is once you put in your probability, if you've got the very next problem, it's also a probability, you can just go up and hit enter again, and then you can just back up and edit. And some people like to do that more than they like to go to math, probability, and then the option. So you can just back up and, you know, change numbers, and it will adjust that. Another thing you can do is hit second enter, and it copies it over, and it just does whatever problem you did last, and then you can go back and you can edit something there. And it's just a couple of key presses faster perhaps than the other. So that finishes up this lesson. I hope this calculator information helped you out, and let me know if you have any questions.